Imagine standing in the middle of an Iranian desert in the dead of July, where the daytime air hits a brutal 50 degrees Celsius. Sweat evaporates before it even forms. The ground scorches through the soles of your sandals. Now imagine walking into a dusty storehouse in that exact same desert and being handed a block of solid ice, cold enough to numb your fingers. No freezers, no electricity, no refrigerant gas of any kind, just mud, straw, and starlight. Over 2,400 years ago, Persian engineers were producing and storing solid ice in one of the hottest climates on Earth, and they were doing it every single year, without fail, using nothing but the physics of the night sky. How is that even possible? Let's break down one of the most underrated engineering achievements in human history. Back in the era of the Achaemenid Empire, around the 5th century BC, Persia's cities were spreading across brutal, arid plains where summer temperatures regularly crossed 45 to 50 degrees Celsius. For most of the ancient world, this kind of heat meant one simple rule: ice was fantasy. You could find snow on distant mountaintops in winter, but keeping it frozen through a scorching desert summer should have been physically impossible. Yet Persian royalty was serving ice-cold sharbat, a chilled fruit drink, at banquets held in the middle of the hottest season of the year. To modern engineers, this sounds like a contradiction. To the Persians, it was simply Tuesday. The secret wasn't some hidden source of ice hauled in from far-off glaciers, although that method did exist elsewhere. The real breakthrough was that Persian engineers figured out how to manufacture ice locally, from scratch, in the heart of the desert itself. And the method depended on a phenomenon most people have never even heard of: radiative cooling. Here's the physics. During a clear desert night, with no clouds blocking the sky, exposed surfaces radiate their heat directly outward into the vacuum of space. There's no blanket of cloud cover to trap that heat and bounce it back down. This means that even in a region baking at 50 degrees Celsius during the day, a flat, exposed surface can lose enough heat overnight to drop several degrees below freezing, even while the surrounding air technically sits above zero. It sounds like a loophole in nature, and in a sense, it is. Modern physicists still use this exact principle in experimental cooling technology today. Persian engineers discovered it thousands of years before anyone had a word for thermodynamics. To exploit this loophole, they built one of the strangest and most brilliant structures in ancient architecture, the Yakhchal, which literally translates to ice pit. From the outside, a Yakhchal looked almost like a giant beehive rising out of the desert floor, a tall conical dome made of a special heat-resistant mortar called sarouge, a mixture of sand, clay, egg whites, goat hair, and ash, engineered specifically to reflect sunlight and resist heat transfer. Underneath that dome sat a deep pit, often extending many meters below ground, where the real magic happened. But the dome alone wasn't enough. To actually create ice, Persian engineers needed a very specific piece of land positioned just outside the Yakhchal, a long, shallow, east-to-west facing wall built purely to cast a permanent shadow. This wall blocked direct sunlight from ever touching the freezing basins beside it, even during the harshest parts of the day. In the shadow of that wall, workers dug shallow, wide pools and channeled water into them, sometimes fed by underground qanats, the same ancient aqueduct systems used to cool Persian homes. Every night, once the desert sun dropped below the horizon, that shallow water lost its heat rapidly through radiative cooling, without cloud cover to trap the warmth, and shielded from any residual daytime sun by the shadow wall. The water's surface temperature plunged, sometimes freezing solid before sunrise, even when the air temperature technically stayed above 0 degrees Celsius. It's a detail that trips people up constantly. The water wasn't freezing because the air was cold. It was freezing because it was radiating its own heat directly into space faster than the surrounding air could warm it back up. Before the first rays of sunlight could threaten to melt this overnight harvest, workers were already out collecting the ice. Thin sheets were broken apart and rushed underground into the Yakhchal's massive storage pit. Down there, in near total darkness, the ice was stacked in careful layers, insulated from each other using straw, sawdust, or dried plant material to prevent the blocks from fusing together or melting against one another. The conical dome above worked like a passive chimney, encouraging warm air to rise and escape out through a small opening at the peak, while the below-ground pit stayed naturally insulated by the surrounding earth. Some Yakhchals were even connected to nearby badgers, the same wind-catching branching towers used to cool Persian homes, funneling a constant trickle of cooler air down into the ice chamber to help preserve it even further. The results were staggering. A single Yakhchal could store tons of ice, harvested drop by drop across the cold desert nights of winter and early spring, and keep it frozen solid all the way through the punishing heat of summer. This wasn't a lucky one-off. It was a repeatable, engineered system, refined and rebuilt across the Persian Empire for well over 1,000 years. Some Yakhchals in Iran are still standing today, silent monuments to a technology so effective that it didn't need a single watt of power to outperform anything else on the planet at the time. Think about what this actually means. While much of the ancient world considered ice an unreachable luxury reserved for mountain regions, Persian engineers were manufacturing it inside one of the hottest deserts on Earth using nothing but geometry, shadow, and the night sky. They didn't fight the desert's extremes. They studied them closely enough to find the one narrow window, a clear night sky and a well-placed shadow, where those extremes could be turned completely against themselves. And the story doesn't end in the past. Modern scientists studying passive radiative cooling, the same phenomenon baked into every Yakhchal, are now developing next-generation cooling paint and building materials designed to cut air conditioning costs without burning a single extra watt of electricity. Engineers today are essentially rediscovering a version of the same trick the Persians mastered over 2,000 years ago, just with better materials and modern testing equipment. It turns out that one of the most promising technologies for cooling our overheating cities was sitting in the Iranian desert this entire time, disguised as a giant mud dome. So the next time your air conditioner bill arrives and the number makes you flinch, remember that an ancient civilization once produced ice in a desert in the middle of summer without burning a single drop of fuel. Would you trust a system like this over your modern AC unit if it meant slashing your electricity bill to zero? Let me know what you think in the comments below. If this deep dive into ancient engineering blew your mind, make sure to like this video and subscribe for more incredible stories of forgotten technology. Thanks for watching, and I'll see you in the next one.